Objectives of the discussion. At the end of this topic, the viewer should be able to identify and understand the meaning and concept of rectilinear motion. Determine the equation used in rectilinear motion. Able to solve problems involving rectilinear motion. Be able to identify and understand the meaning of free fall and the condition under which it occurs. Determine the equation used in free-falling bodies. Solve problems involving free-falling bodies.
Rectilinear motion. Before we go to rectilinear motion, first, we need to know what is motion. Motion is one of the most common phenomena we came across in our daily lives. For example, a moving car, a kid running on the road, or a fly moving in the air are all said to be in motion. So in general, a body is said to be in motion if it changes its position with respect to a reference point and time. So what is the difference between distance and displacement? Distance is defined as the total path length covered during a journey, while displacement is defined as the path length from final position of the particle to the origin O. So what is the difference between speed and velocity? The speed is the rate of change of distance, while velocity is the rate of change of displacement. Speed is equals to distance traveled over time taken. Velocity is equals to the final position minus initial position over time taken. What is rectilinear motion?
Rectilinear motion is a motion of a particle or object along a straight line.
Do you wonder, what are the examples of rectilinear motion? First, the use of elevators in public places is an example of rectilinear motion. Gravitational forces acting on objects resulting in free fall is an example of rectilinear motion. Kids sliding down from a slide is a rectilinear motion. The motion of planes in the sky is a rectilinear motion. These are some of the examples of rectilinear motion. So, there are three types of rectilinear motion. First is the uniform rectilinear motion. Second, uniformly accelerated rectilinear motion. Third, rectilinear movement with non-uniform acceleration. Uniform rectilinear motion. When an object travels at a constant speed with zero acceleration. Uniformly accelerated rectilinear motion. When an object travels with constant acceleration. Rectilinear movement with non-uniform acceleration. When an object travels at an irregular speed and acceleration. What is a free-falling body?
Free fall. A body that moves freely in the presence of gravity and it has a constant acceleration, which is the acceleration due to gravity with a value of 9.81 meter per second squared.
We have two sign convention in order to solve the problems under the free-falling bodies. Upward motion is equal to negative gravity. Downward motion is equal to a positive gravity.
These are the formula for uniform motion, where d is equals to distance, v is equals to velocity, v sub o is equals to initial velocity, e is equals to acceleration, t is equals to time, g is equals to acceleration due to gravity. If the movement of the object is upward, we will use the negative value of acceleration due to gravity, and vice versa if it is moving downward. You can use this formula depending on what you need to solve. In free fall, we are using the value of g instead of a, since g is the acceleration due to gravity.
Did you know that in between the year of 1589 and 1592, the Italian scientist Galileo Galilei is said to conduct an experiment dropping two spears of different masses from the Leaning Tower of Pisa to demonstrate that their time of descent was independent of their mass.
Sample problem number 1. What is the acceleration of the man with a bike that increases in velocity from 20 meter per second to 40 meter per second in 3 seconds? First step in solving the problem is writing the given. We have initial velocity equals 20 meter per second, final velocity equals 40 meter per second, and time equals 3 seconds. The required value is the acceleration. And for the equation, we will use the formula final velocity is equals to the sum of initial velocity and the product of acceleration and time. For the solution, we substitute our given into the formula. 40 meter per second is equal to 20 meter per second plus acceleration multiplied by 3. Now, the value of acceleration is 6.67 meter per second squared. Sample problem number 2. A ball is thrown vertically upward from 5 meter above the ground with a velocity of 11.72 meter per second. Find the distance at the peak. The given are initial velocity equals 11.72 meter per second, final velocity equals 0 meter per second, and g equals negative 9.81 meter per second squared. Since it is thrown upward, we will use the negative value of g. The required is the distance y. And to solve it, we will use the equation the squared of the final velocity equals the sum of the squared of initial velocity and twice the product of acceleration due to gravity and the distance y. For the solution, we will substitute the given in our formulas. 0 is equals to the quantity 11.72 meter per second, the quantity squared, plus twice the product of negative 9.81 meter per second and y. We can now solve the problem. The value of y is equal to 7 meters.